Hi, this is Mrs McTaggart, and in this video we're going to look at some reverse volume questions. Now when I teach volume, I generally embed these through my teaching, so whenever I teach sphere, I'll show a backwards one to get the radius, etc. But what I've found is a lot of times this is a part that my National 5 pupils struggle with, so I felt it was worth making a video that just focused on doing reverse volumes. So I'm going to do one from each common National 5 shape. Now there's two possible methods here. So this video I'm going to use the method where pupils change the subject first and then stick the numbers in, which is great on the new Casio calculators. I do have another video which is maybe for some other classes that aren't brilliant at change the subject, where we stick in the numbers first and then play about with the formula. So make sure you're watching the right one to what you did in class. So let's get straight into some examples. So example 1 here has got a pyramid and it tells us the volume. We can see that it's a square base pyramid by the fact that both of these sides are 9. And what it's asking is to find the height. So the first thing we're going to do is we're going to start the formula. Formula for a pyramid is V equals 1/3 AH. Now we're going to rearrange this to find H because the question says find height. So we're going to change the subject to H. So the first thing we do is we're going to do the opposite of a third. So the opposite dividing by 3 is times by 3. So we end up with 3V equals A times H. Then we're going to get rid of the times by A by dividing. So we get 3V divided by A equals H. So to get the height, we are going to substitute in and say height equals 3 times the volume. So V gets replaced with 162. And the area of this square on the base would be 9 times 9, which is 81. And then we're just going to go to our calculator and type that in, and you get an answer of 6. Now you don't always get a perfectly nice answer, but for my examples I generally try to keep them nice so you can get an idea if you've got it right. So just to recap what we did there, we changed the subject to the formula to H first of all, then we stuck in what we knew, which was the volume and the area of the base, and we got the answer of 6. Let's look at our next one. So example 2, instead of doing a sphere, I thought let's do a hemisphere. So we want to find the radius here. So I'm going to start with the formula for a hemisphere. So a hemisphere is 4/3 pi r cubed and then divide by 2. Now some people might just half the 4/3 and write 2/3. I've found that my pupils struggle with that a wee bit and like to just stick the divide by 2 on the end. Now we're after the radius, so we need to isolate r in this case. Now this is probably the trickiest of them all. So to change the subject, I need to do the opposite of times. There's a divide by 3 here and there's also a divide by 2. So I need to do the opposite of dividing by 3 and the opposite of dividing by 2. Now we would multiply by both of them. And if you times by 2 and then times by 3, you're effectively timesing by 6. So we're going to end up with 6 times our volume equals 4 pi r cubed. Then we need to get rid of this 4 pi. The 4 pi is multiplying the r cubed, so we divide by 4 pi, and we can just take them together as one term, which gives me r cubed. And from there, I need to take the cube root. So r equals the cube root of 6 times my volume all over 4 pi. Now at this point, I'm ready to do my substitution. So my radius is the cube root of 6 times my volume, all divided by 4 pi. Let's just make a wee bit more room. And if you've got your calculator set onto the Casio mode, where you've got the fancy fraction button, this is a doddle to put in. So if you've got your calculator set onto that mode where it's a fraction button, you'll get your cube root, then you'll hit that fraction button, and then you'll just put in the numbers you've got, and you'll get it all in one go. And you get the answer of 8.9924 and so on. So I think that's pretty safe to say that my radius was 9 centimetres. Now if you don't have the Casio calculator, you might have to work out the bit underneath the square root first. So you may have to do this bit there first of all, get that number, and then take the cube root of it. But honestly, this is really easy if you've got the Casio on the fraction mode. Okay, and if you can't find your cube root, remember it's hidden above your square root, so you have to do shift of your square root button. Okay, next one, I've got 2 cone ones to do because there's 2 different scenarios in the cone. We can either do it where we ask for the height, or we can do it where we ask for the radius. So in this one, I'm going to do the height first because that's got less work in. So we're going to start with the formula for cone. V equals 1/3 pi r squared h. Okay, and in this one, we are after h, so we need to deal with moving everything else. So let's deal with the fraction. Opposite of a third is timesing by 3, so we have 3 times our volume equals pi r squared h. We then need to deal with the times by pi r squared h, so we can move that as one term. So 3v over pi r squared equals h. And at that point, we can just plug in our numbers, so I'm just going to reverse it. So my height is 3 times 821, because that's my volume, all over pi times, now my diameter is 14, so my radius is 7. And if you type that in, you get 15.9999999. So I think that's safe to say that my height was 16 centimetres. Now remember, you can always check these when you're done. You can go back and plug the height back in and do a third times pi times 7 squared times 16. And you should get really, really close to 821. In fact, you should get 821 because that's the number I used to get my answers. So that's the simple cone. We have to get the height. This one is wanting the diameter, so effectively it's wanting the radius first. So this one's a wee bit trickier because involves squares and a slightly different order of change of subject. So as always, we'll start with the formula. V equals 1/3 pi r squared h. Now to get the diameter, I need to isolate r. So once I get my radius, I can double it to get my diameter at the end. So same again, fraction. A third, the opposite of a third is times by 3. So you get 3v equals pi r squared h. I then need to undo the times by pi and the times by h. So what you can do is you can take them collectively as one term again and do 3v over pi h equals r squared. And then r would be the square root of that. And I'm just reversing it over because I like my r on the left-hand side. So your formula is 3 times your volume divided by pi h and then square root it. So now we can put in our numbers. So we have the square root of 3 times, I've typed that wrong, 3 times 382 all over pi times, now the height of the cone is 18. So then again, if you've got that fabulous fraction button, you can just do this in one go and you'll get the answer of 4.50. So my radius that I used was 4.5 centimetres. If your radius is 4.5, then your diameter is double that. So diameter in this case was 9 centimetres. Okay, so again, just to recap, if you don't have that fraction button, you will have to possibly type 3 times 382 divided with brackets around it, divided by bracket pi times 18. Get your answer and then square root your answer button. Okay, if you don't have your calculator on the good fraction mode. But it's a lot of work in and it just makes the typing in a lot easier to do because you're not actually going to calculate it till the last step. Okay, so I've shown you examples of all the shapes you're asked to do at National 5. If you wish, here are some you can try on your own. When I teach this to my class, I then go get them to pick any 3 to do. So you've got a wee mixture there and then you can pause it and try them. And when you're done, you can unpause it and then here are your answers. So good luck, thanks very much for watching. Bye-bye.